Our goal is to share with you the data science way of AI development cycle, which will elevate your LLM game. So what's all the buzz about generative AI? With the release of ChatGPT in November 22, we all had an easy access to a tool that was genuinely game-changing. First, it's incredibly user-friendly. You can just communicate with it in plain language. Second, it's amazingly versatile. Whether you need a poem or a piece of code, it can handle it. And the quality of the output is impressive. And perhaps most importantly, it can speed up your daily tasks with barely a minimal effort on your part. This powerful combination has essentially democratized AI. It's no longer just for tech experts. It's a powerful tool that anyone can use. But what does it mean for us at Wix? So at Wix, we witnessed an interesting phenomena. Wix was an early adopter of this technology, with first working GenAI application in production as early as May 22, even before ChatGPT was released. What made it possible is the unique Wix ecosystem, encompassing a boost from the management to experiment with this technology, as well as talented, curious, creative employees, yes, this is you guys, eager to explore and try it out. Since the first adoption of GenAI technology, we're currently seeing being used all across Wix. We have it integrated in the main funnel. Vast majority of our newly created sites are getting AI-generated content. Customer care chatbot is powered by AI, and it gave a major boost to Wix internal velocity. And these were just a few examples. The extensive usage of AI is shown here in the following numbers. So we have more than 6,000 prompts that were written by more than 600 employees, resulting in 4.5 million daily requests. This is pretty amazing, right? Looks like everyone at Wix are using GenAI. While it's clear that AI usage has skyrocketed across the company with impressive engagement from our employees, we at the data science team has had a unique perspective in observing and guiding this complex journey of scaling AI at Wix. Over the past 2 years, we had a horizontal overview of this process. We accompanied many projects and teams who are trying to build their own AI-powered products. We also invested much time and effort in learning and researching this new technology. And what we can definitely say today is that developing LLM applications is extremely challenging. But wait, it's supposed to be easy. It's only about prompt engineering. We only need to write instructions in human language. What can be so challenging about it? So the thing is that we basically have too many moving parts. Firstly, the input to the prompt typically comes from humans, making it inherently difficult to predict. These inputs are then incorporated into the LLM prompt with the expectation of a specific output. However, LLMs are highly sensitive to the way we communicate with them, and even a minor change in wording of the prompt instructions can lead to different results. And finally, the outputs generated from these prompts can vary significantly, even when using the exact same input and prompt. I think at this point of time, you would all agree with me that this is not an easy setting to build applications. It is much different from the classical R&D flow that all of you are familiar with, which is much more deterministic. But what if I tell you that there is a way to overcome these challenges? Like I mentioned before, AI applications development cycle doesn't suit traditional programming practices, but it does suit the traditional evaluation-driven development cycle that is being used for decades in the data science community. And this is what Ola is going to demonstrate next.
Thank you, Olga. Thank you, Olga. And before we continue, I actually would like to know my audience. So how many of you ever interacted with ChatGPT or any other GenAI tools? Everybody, obviously. How many are using these tools for their daily productivity? Almost everybody. And the last thing, how many of you created prompts that are in production today or maybe about to go to production? Okay, much less, but actually we have a really good crowd here. And please pay attention, I'm going to ask you another question in the end of the session. So what Olga was talking about, I'm going to demonstrate afterwards through an example. And this is an example that I'm going to show that actually showcases the common practice how people are working with GenAI tools today. An example is very simple. It's basically we are analyzing the message that user sent in a funnel chat and try to extract the business name out of it. Very straightforward. So how do we start? We start from writing our first prompt. So we are writing a very simple prompt, analyze the user message, and extract the business name. Very clear exactly what we wanted to achieve. And then we are testing it on an example, our input, and we check the output. And as you can see, LLMs love to talk. So it gave us too much information. Let's refine it. How do? We go to the prompt, and we're adding like another sentence, trying to get better results. It works. Great. So what next? We take a different example. We test it. And for this example, where we have two business names, it failed, and it's not what we wanted. We go again to the refinement. And essentially, what happens that basically this is this iterative process of taking one example, checking, drawing conclusions from the output if any work should be done on improving the prompt, and moving on. And the thing about it, it actually leaves you in this state of uncertainty. Okay, wait. Should I continue, try more examples? Is it good enough? Can I go to production with it? You have no idea. Or maybe you say like, wow, this is great. Or the opposite. It's not going to work. It's never going to work. So this state of uncertainty and sometimes frustration, it's not the worst thing. The worst thing that this method is wrong when you work with AI models. First of all, why? Because it can create false confidence. The examples that you selected can be very simple and pass this prompt, but then when you release it free in production, you might get very different experiences and create very embarrassing, even harmful results for our users. Second thing, you can overfit. Basically, the example that you checked on is so niche and so rarely happens that you overcrafted, created this huge prompt just to make sure that it passes, and eventually it cannot generalize. It's not going to be performing well. But more generally, it's also you are not really able to compare between versions of the prompt. So you had example that passed, you test new example, it didn't, you created new version of the prompt, but can you say by how much the new prompt is better than the other prompt? Is it even better? Can you guarantee that the new version of the prompt that you created actually will do well on the example that passed on the previous version? You have no idea. And this is where this AI development cycle will come to help, because this is the way that you need to work. And one thing that is important to mention, this GenAI new technology, as any other, requires you to pick up a new set of tech skills. So, but it's beyond that. The moving from the traditional development into AI development requires you to change the mindset. It's not about trying to get something to the state of done and go to production and maybe do some bug fixes. It requires you to do the iterative cycle of constant ideation, experimentation, looking at the results and refinement. And this is something that is really, really important to understand, that AI development is so different from what we are used to. And when talking about like very abstract, high level about the GenAI development flow, we have 3 blocks there. The first block is the modeling part, which basically we are having the LLM, and we write prompt that communicates with it. Second part is the evaluation, and the third part is the production. So traditionally, you would go quite linearly of modeling or algorithm development, testing, and then production. But the thing about the cycles that I mentioned before, the evaluation is in the heart of it, and the evaluation has the bidirectional connection between all of the pieces. And that's the core of the talk that I'll be giving now. So what is the evaluation? Evaluation has 3 ingredients. We have a test set, success criteria, and performance metric. So what is a test set? A test set is simply a collection of inputs that will be processed by your prompt. It also comes with expected output, the output that you hope that your prompt will return. And what are the characteristics of this test set? First of all, volume. You cannot evaluate AI models on one example. You cannot say, yes, it works or doesn't work. You can say that the AI model works in 80% of the cases. So we need to have at least few dozens of examples of the inputs. Plus, you need to add diversity. As users that will be interacting with the AI feature can produce different inputs. It can be short, it can be long, it can be very complicated, or very simple, or even irrelevant. You need to make sure that you account for these examples in your test set. And the very, very important part, it has to be as close as possible to reality. Ideally taken from production. But objectively speaking, when you work on the AI feature, you don't have it out there yet, so you don't know how people interact with it. So we need to simulate the closest possible inputs that you assume people will pass into this prompt. Okay, so, and basically you remember the example of extracted business name? So now we have this CSV, Excel, Google Sheet, doesn't matter, with a lot of messages as input, and the expected output, what we hope the prompt will return. What can we do now? We're just sending all the inputs into our prompt, and we get the model outputs. Very simple. Instead of one example, we process the entire test set. And now the very important part of evaluation comes is success criteria. What is success criteria? It's basically when you look on the output of the prompt, is it good or not? So what is this definition that will tell you if it's good or it's bad and insufficient? And for our specific example, okay, good, it means that the correct business name was extracted. And we start checking. We can compare our expected output to model output. If it's equals, it's correct. If it's different, it's incorrect. But this example is very simplistic. Important to understand that for different features, for different use cases, you might have multiple success criteria, and they might not necessarily need the expected output. If, for example, we are trying to write a paragraph for a website, then we cannot really write this paragraph in advance and assume, like, we don't want that. We want it to be creative. So the success criteria could be, is this paragraph relevant for the business type of the user? It can also be if the length of the paragraph, if within certain boundaries, because you are bounded by placeholder on the website. So there can be like a variety of different success criteria that are specific for your use case, and it's a very important point to stop and focus on how you define it. And then the last thing is performance metric. So the success criteria you can define for each of the input if it passed or it didn't. But for eventually, you want to say one numeric value of the performance of your prompt. And basically, it's just aggregated view of the performance, and there are different ways to calculate it, depending on your use cases. But in most cases, it's quite simple. You basically try to calculate, like, what is the share of correct extraction versus incorrect. In this simplistic view with 3 examples, we are at 66%. Great. This number now is extremely valuable because we are able to test different versions of the prompt and compare if we are improving or we are actually making it worse. And additionally, it also gives us a decision point. Instead of understanding, like questioning, is it good enough? Should I go to production? You now have a decision-making point that is very deterministic. Is it good enough? And in this case, it's not good. So what do? We go through a standard process of error analysis. We look at our test set, we start looking at the examples where we failed, and we try to generalize how can we make the prompt better, not to miss in the next iterations. Okay? So as I said, we have our performance metric, and we can now change our prompt. We can change different versions of the model. We can do whatever we want, and we have ability to compare and to see which direction it takes us. Until to the point that we see, okay, the performance is good, I want to deploy, I want to go to production. So great, it seems that we are done, but it's really not done when it comes to AI. Because until now, what happened that we tried to simulate what would be our user's input. But the model is in production, so we are able to collect the data and actually reflect the reality in our test set. And we don't know, like when you expose these features, people can talk in so many different ways that maybe we didn't even anticipate. And we want to make sure that we are covering it. And how do we do that? So basically, we are doing the production alignment of the test set. We have the 3 simple steps. So the feature in production, we have a lot of data. Let's sample this data of the inputs and review them. After that, we revisit our test sets. If the original test set was something that we generated from our imagination, we start from scratch. We again need these few dozens of examples that represents happy flows, basically easy messages, like that the way that user behaving in a natural way as you expect, actually write business name. Also edge cases, maybe people write paragraphs or speak in some things that we didn't account for and we want to include. And also we want to add the failed prediction of the production prompt, where did it fail, and because we want eventually to fix it. And then we repeat the process. We repeat evaluation and we improve the prompt. We have a better, newer version to the prompt, we go to production. And we already did a much better process than originally trying to do everything on one example. So now it's done, but this GenAI world is very exciting. Almost every week we get some news, and periodically we get new vendors popping up, new versions of the models showing amazing results on different scoreboards. So sometimes it feels very tempting, okay, I'm just going to switch from this version to this version, and it's going to work great in production for me with 0 efforts. Or the second thing that we already experience is models get deprecated, because we are relying on third-party applications, third-party vendors that can decide we are killing this version. And that's the version that runs in production. So what you need to understand, the public benchmarks, all the scoreboards and ranking, these are not your use cases. It's not necessarily will represent exactly the same improvement of performance on your data. And the second thing, the prompt may need to be readjusted for a new LLM, new vendors or new versions. There are different models have different sensitivity to the way you communicate with them. So it's important to understand that nothing is just given, you need to put work into it. And how do you understand if you need to put work into it or how? You evaluate, because we have all the pieces already in place and you can make conscious decision if you want to do this move or not. So essentially, when it comes to developing the AI features, the artifacts of it are not just prompt. It's a prompt, it's a test set, the one that we aligned from production, definition of success criteria and performance metric. And it all lives together, and it's going to serve you a long way when it comes to the maintenance. And just to recap, evaluation-driven development, it helps you build better AI solutions. It helps you also to understand directions of improvement for the prompt engineering parts and also the model selection. And essentially, it saves you time, even though you need to put resources on collecting these examples, building test set, calculating the quality criteria. But essentially, you are able to be more confident on what you are releasing, to be more confident that the changes you are making actually exactly what you need it to happen, and it directs you the path of the improvement instead of shooting everywhere. And essentially, working with AI solutions, evaluation-driven development is a must. And I'm telling you this as a data scientist who's been working like this for a long time. The model is going to get better. A lot of things going to change. And maybe we will not even be writing prompts. But we still have to have this method in place. And that's, I hope, the takeaway that you're going to take from here. Like, don't be afraid of evaluation. Make sure you do it. It's important. And just to tell you like a few more things, you don't have to do it all by yourself. In the Prompt Hub, you have ability to upload your test sets, to connect it to the prompt, to evaluate the quality of it, define your metric, and compare different versions of your prompt and its performance. So it's already given out there. But another thing, what I showed you, the example was very simple. And we do know the evaluation for different features might require more effort and more work on trying to define how to do it. please come to us. Please come to data science, share your examples, let's think together, and we will try to help to build you the best evaluation policy. And I promise one more question. So the people who raised the hand when they said about prompt in production, who did the evaluation-driven development? Data scientists can lower the hands, but so I hope that next time we talk, it's going to be a very different situation. Thank you so much, and I really mean talk to us.